Welcome everybody to this module of our Advanced Technologies class on demand. My name is Anthony Sequeira and I'm thrilled that you're joining us here for this look at VLANs, trunking, and the VLAN trunking protocol. We're going to have lots of fun in this lesson as we take a look at some key topics that every CCIE candidate should be well versed in for the CCIE lab exam. Now, while this is Tier 1, more foundational training from us here at Internetwork Expert, you have to remember something, and that is the fact that we are preparing for the lab. I mean, that is the ultimate goal, is to get you past the lab exam. Again, we have great courses here that are going to simulate the exam and give you sample exam tasks, and this isn't one of those classes, but we definitely want to have our eyes on the prize, so to speak. We want to be thinking constantly about passing the CCIE lab. So something that I want you to be thinking about as you experience these lessons on the Catalyst switches is that we can definitely expect Catalyst switch troubleshooting to appear in the lab exam. Remember, as of the current version 4 blueprint, there are no switches to troubleshoot in the troubleshooting section of the lab exam, so we can definitely expect some switch troubleshooting in the configuration portion. One of the things also I want you to begin thinking about strategically here is right away when you're looking at switching tasks, you want to start mentally separating what are core tasks from non-core tasks. By core tasks, I define this as a task that impacts other points. So a core task would mean that if we don't get something working, it will impact the losing of other points. It'll make us lose other points. So there's a dependency. I consider a non-core task to be that one that if we don't do it, no problem. It won't affect any other points in the CCIE lab exam. As you might guess, most of your Layer 2 tasks that we're going to look at in this chapter, they're going to be core tasks. Most of them will definitely be core. If we don't get our Layer 2 all happy, we won't get our Layer 3 happy. And therefore, we're going to have this cascading point loss effect. So we want to be real sharp, real well versed in these Catalyst switches, and I'm sure you're going to feel so after these lessons. We're certainly going to be doing lots of hands-on demonstrations in this particular course, so one thing I need to do right now is I need to jump over and get on some rental equipment. Let me just walk you through that process right now. So I'm going to go to my Internetwork Expert sign-in page, and I'm going to go ahead and sign in. And then once I'm in, I'm going to go ahead and make sure I rent some rack time and get the rack appropriated for this particular class. So I'm going to go over to the Rack Rentals tab inside the course, and I'm going to bring up the RNS Rack Rental Scheduler. Move this so you can see it. I'm going to be on the equipment all day long, so I'm going to go ahead and schedule all of those slots that are available. And we see that I get confirmation of those racks that I scheduled. We're going to go ahead and close that up. Now if I go back to the rack rental page and we scroll all the way down, we can see my sessions lined up for today. And I'm going to go ahead over to the control panel now. What we're going to do in the control panel is we're going to go to the Config Options button. And if we scroll down, notice we can save our configs. We can load configs we've saved and rename them with this tool. If we scroll down, we can see there is a Load Products Config area. Lots of products that we have and their initial configurations can be loaded through this tool. And the one that I'm going to go ahead and use, which will be fine for the advanced technologies, is just a very base basic set of configurations, basically just naming the various devices for me, and that's IEBC RSV11 base config. That'll do just fine. All the base config file does, even though it was specifically designed for our boot camp, it's just going to just give you host names, basically. I think it does put a loopback interface on each of the devices as well, but this will be perfect for us for our experimentation and our practice inside our advanced technologies topology. By the way, we'll do all of the demonstrations using the Advanced Technologies class topology, which is available for you to look at in your members site. You might want to print that out, as we'll be using it as the topology in all of our demonstrations. I'm going to click the Load Config button and confirm that I want to load this config on my rack of equipment. And what's going to happen is it's going to clear the rack of equipment and then put these initial configurations on. If you scroll back to the top, you'll see this spinning wheel here, and it says please wait. This configuration process takes about 20 minutes, and this will go away. This will disappear when the process has completed. All right, everyone. Well, now that I've paused the video, obviously, and we've made sure that our rack was prepped, let's go ahead now and connect to the rack. I'm using Secure CRT. You can use whatever software that you like. I like to stick with Secure CRT because it's Cisco's standard for the CCIE lab exam. So I'm going to go ahead and connect here. I'm going to use my rack and my password. AF7. Oh, I almost spoke my password. Yikes. All right, let's see. Here we are at the terminal server. I'm going to make my connection to R1, R2, Control-Shift-6X, of course, gets you back to your terminal server. R3, Control-Shift-6X. We're back to R4. Whoops. Switch 1, switch 2, switch 3, and finally switch 4. Now if I do my show sessions, I can see throughout all my demonstrations, I'll just be tapping 1, 2, 3, 4, 5, or 6 to get to those devices respectively. I'll be doing 7, 8, 9, 10 to get to my switches. So, we're all set up and ready to go. Let's go ahead, take a look at some VLAN content, and then get right back on this equipment and see it come to life at the command line. In the CCIE lab exam, the version 4 lab exam, you're going to be contending with 4 3560 catalyst switches. That's 4 3560s. And this is going to mean that you can have all kinds of different layer 2 switch ports, as we see, and all kinds of layer 3 port structures. For the layer 2 switch ports, you can have access ports, trunk ports, tunnel ports, dynamically selected ports, as we'll see. And for the layer 3 ports, we're going to look at switched virtual interface ports as well as native routed interfaces. Now, I'm sure from your CCNP training here you are familiar with all of these structures, but we will be reviewing them as we move throughout this lesson. Access ports on a catalyst switch only belong to one VLAN. That's right, one VLAN for the access switch ports. Now, there are exceptions to this, actually. Isn't it interesting with Cisco Technologies? We teach something, then we always have to start talking about the exceptions. The exception with an access switch port is the auxiliary VLANs we can create for things like voice traffic. But that's not our concern at this point. It's just the concept of a switch port participating in a VLAN. Let's jump to the command line and take a look at this. Here we are back at the command line, and what I'm going to do is I'm going to jump over to switch 1, for instance. Let's jump over to switch 1. Now, on switch 1, I'm going to go ahead and do the following. I'm going to say show run interface for the Fast Ethernet 0/7 interface. And if you look at this, you see something very interesting. There's no configuration there, none whatsoever. That's interesting. So it's unconfigured, and we don't really know what its default characteristics are. So let me do a show interface Fast Ethernet 0/7 switch port. The show interface switch port command, and I apologize, I abbreviated it there out of habit, but I will try and give you full commands throughout these recordings. But anyways, the show interface Fast Ethernet 0/7 switch port command, this gives us a lot more information about what's going on with the port. We saw that we didn't see any configuration under it. Now we see much more information, like it's enabled, it is in the dynamic auto mode, and its operational mode is down. Nothing's plugged into it. But this is what I was most interested in. It's in the dynamic auto mode. So it's not a access port, it's not a trunk port. It's hanging around right now trying to decide what it's going to be. Let's do a show version on this particular device. And yeah, we see it's a 3560. It is one of the 3560s like you would have in the lab. So that Fast Ethernet 0/7 port is defaulting to a dynamic auto mode, and it wants to automatically negotiate whether it's going to be an access port or one of these trunk ports. Well, let's make up its mind for it. Let's force it. Let's say, hey, Mr. Fast Ethernet 0/7, you're in fact going to be an access port. And here's how we do that. We say interface Fast Ethernet 0/7, and then we're going to say switch port mode access. Now, that's actually kind of an optional command here, but I love to use it. We say, look, you are an access port. Make no doubt about it, you are an access port. This is technically the dynamic trunk protocol's mode of off. Okay, this is DTP mode off. We're saying you are not a trunk, you are an access port. And now we say switch port access VLAN, and we put it in, let's just say VLAN 100. Now it says, wow, access VLAN 100 doesn't actually exist on this switch, so we're going to go ahead and create VLAN 100. Great. So now we have just changed the characteristics of this port for sure. It is now a layer 2 access port. I said this was kind of an optional command. What we could have done is just said switch port access VLAN 100, and that would have placed it in access mode for this VLAN of 100. Well, actually, let's experiment with this. This would be well worth seeing. Watch this. I'm going to say default interface Fast Ethernet 0/7. Okay, so we're set to the default configuration. All right, now let me say interface Fast Ethernet 0/7 switch port access VLAN 100. All right, now let's see about the characteristics. First of all, a show run interface Fast Ethernet 0/7. Okay, it just shows the one command under there where we're putting the interface into a particular VLAN. And now let's rerun our show interface Fast Ethernet 0/7 switch port. Ah, look at this. It's still in the dynamic auto mode. It's still in the dynamic auto mode, and it wants to be an access port in VLAN 100, but notice it's still set to dynamic auto. We could have this interface automatically become a trunk. I don't like that. I'm going to go in and say, look, switch port mode access. Now let's rerun our show interface switch port command. Yeah, this looks a lot better. Now we're in a static access configuration, and we're in VLAN 100. I like it. You might get points in the CCIE lab exam for either configuration, but I'm sure you'll agree that one is more precise. In fact, one is more safe as well. So we've taken a look at the access switch port, and we're going to be elaborating here on the trunked switch port. We've also alluded to the dynamic DTP negotiated ports, and we've seen those at the command line. Let's take a moment to talk about tunnel switch ports. What are we doing when we have an interface tunnel? Well, for that, I want to go ahead and jump with you up to one of the, in fact, not one of, for me, the most important place on all of Cisco.com. It's the documentation CD interface that we will have access to in the CCIE lab exam. All right, here we are at the doc CD interface. As a matter of fact, let me back up and show you how I got here. Obviously, we're going to start out at the Cisco homepage, but then what you want to do is you want to go ahead and click on Support Configure. And this is going to bring you to this Select Your Product or Technology interface, and this is where you're going to be dropped off when you select the doc CD link in the CCIE RNS exam. So you want to start learning technologies and practicing with your technologies using this as your companion, just like you would have in the lab. So I'm going to go ahead and say switches, and then I'm going to say LAN switches, and then I'm going to say the 3560 series of switches, and we're going to go to the configuration guides. Once in the configuration guides area, I'm going to go ahead and click on the 3560, and that's going to bring up a new window. And if we look over here on the left-hand side, we should see, there it is, IEEE 802.1q and Layer 2 protocol tunneling. Let's go in here and let's take a look at an example. This is what tunneling is all about. Here you can see we have a service provider, and the service provider has this customer A and this customer B, and the service provider has a problem when it comes to carrying the traffic of these customers. If the customer's switch is going to connect directly to the switch of the provider using something like a Metro Ethernet connection, for example, there's going to be a big issue. Notice that customer A is using VLANs numbered from 1 to 100. And customer B chose numbers from 1 to 100. They actually went 1 to 200, but you can clearly see there's going to be a potential overlap here. Customer A uses VLAN 10, for instance, and customer B uses VLAN 10, for instance. So we're going to have an overlap. What you do with this tunneling feature is you go ahead and you double tag the traffic. You put what's called a metro tag to identify one customer from another in the service provider cloud. So they'll get two tags, one to identify the particular customer, and then one that's going to be used, obviously, for the customer's VLAN itself. So that's what Q-in-Q tunneling is all about from a high level. And obviously, in our more advanced CCIE training materials, you look at the configuration of the Q-in-Q tunneling feature. When it comes to a trunk link and carrying the traffic of multiple VLANs from device to device, we have the inter-switch link option of trunking, in which we tag all traffic with the VLAN identifier. And by the way, this is a Cisco invention, and it is definitely fading from usage, but we still are responsible for it in the CCIE lab and exam environment. As an alternative to this, the 802.1q approach to trunking is where we have an open standard, non-Cisco proprietary solution, and all the VLANs are tagged with the exception of one VLAN that is sent untagged, and this is the native VLAN. the native VLAN is not tagged, and it is going to be guaranteed, therefore, this traffic to flow over links even if they lose their trunk status. That was the idea, by the way, of the native VLAN concept, for there to be one VLAN that can be proliferated with no tag value whatsoever as a safety mechanism. And, of course, we have been talking about the dynamic trunk protocol, which can be used to negotiate the particular encapsulation that's being used for the trunking and whether or not an interface is going to trunk at all or not. So let us return to the command line and take a look at some of these trunk ports. Here I am on switch 1 again, and I'm going to go ahead and issue a great switch verification command. It's show interface trunk. Are there any trunk ports on this switch 1 right now in its default config? Boy, oh boy, there sure are. Look at this. Ports 16, 17, 18, 19, 20, 21, they're all trunking. They're all trunking. They're all in the dynamic trunk protocol mode of auto, and they negotiated ISL links with their neighbor, and their status is trunking. And this is pretty funny. The native VLAN is 1. But wait a minute. I thought with ISL links there is no concept of native VLAN. Yeah, there isn't. This is here just in case we were using 802.1q as the encapsulation. Notice that all VLANs are allowed over these links, but right now we only are using VLANs 1 and 100 in the topology. Wow, very interesting. So we formed dynamic trunk links here, and we negotiated them to interswitch link. Well, what we're going to do right now is let's go ahead and take links 13 through 15, the links that connect to switch 2, and let's go ahead and manipulate them so we have 802.1q trunks. Let's see how we could do that. And we'll pick on the links, let's see, 16 through 18 that connect to switch 3. And how can I tell 16 and 18 connect to switch number 3? Well, we see that they're trunking, and if I do a show CDP neighbors command, we'll see that our local interfaces of 16, 17, and 18 connect out to switch 3. So we can use show interface trunk in conjunction with show CDP neighbors in order to quickly determine who we are connected to, who are we trunking with. Let me do this. Let me say interface range fast Ethernet 0 slash, let's see, what are we talking about? 16 through 18. And now, whoops, let's type that command again, this time correctly. 16 through 18. Okay, great. Now, for that range of interfaces, let me try this. Switch port mode, switch port trunk encapsulation .1q. All right, that should do it. Notice the interfaces are going to toggle down and then back up. If we rerun our show interface trunk command, we'll see that, we're still forming those trunks, but now we're no longer negotiating the encapsulation. The encapsulation we've hard-coded to 802.1q on this side. Let's go over to switch 3. We should show switch 3 as negotiating the 802.1q. Let's try it. On switch 3, I'll say show interface trunk. Yep, sure enough, over on this side of the link, you can see we have negotiated the 802.1q protocol. Notice the mode over here in these three links was set to desirable. So we automatically formed a trunk because our 3560 switches were set to auto and our 3550 switches in our racks of equipment were set to desirable. The combination of auto and desirable, as you recall from your BCMSN training, that caused a trunk to form. Now, you might ask the question, well, Anthony, why are there 3550s in your rack of equipment? And we always try and build our racks with the minimal equipment necessary in order to satisfy studying for the exam. So Graded Labs, our partner that handles the equipment, made the determination, you know what, we can survive just fine with two 3560s and two 3550s and still keep costs low, both for Graded Labs themselves and for students that want to build their own racks of equipment. Okay, now what if we're not satisfied with this configuration? What if we want to make it so that the mode is not variable? We want to kind of hard code the configuration. Well, that's easy. We're going to go in and we're going to say interface range FA0/16 through 18, and I'll say switch port trunk encapsulation. I'm going to force it on this side too to .1q. And then we're going to go one step further. Notice they're going to toggle from the down state to the up state. By the way, in actual practice, you'd want to shut things down here, but we're just being kind of lazy and quick in this demonstration. So we see now we're no longer negotiating the encapsulation on both sides. Great. And now I'm going to say switch port mode trunk. Now, if we confirm this with our show interface trunk command, we see that, yeah, we are now hard-coded up, and I picked the wrong interfaces. On this particular device, it's 13, 14, and 15 that are connected to 16, 17, and 18. That's funny. So let me just go in and do this for the correct range. Interface range FA0/13 through 15. And I'm going to say switch port trunk encap .1q. And then I'm going to say switch port mode trunk. All right. Now if we do our show interface trunk command, wow. Now the mode is set to on, and you can see we're no longer negotiating the encapsulation. If I go back over to the neighbor device, show interface trunk, we see, and I'm on the wrong device, let's go over to switch 1. So we're going to do a show interface trunk over in switch 1. Look at this now, it's still set to auto. So we've got one last thing to do over here. We're going to go in and enter the range of interfaces, and we're going to say switch port mode trunk. We'll confirm that with our show interface trunk command, and now we can see we're in the on mode over here, and we're hard-coded to 802.1q. Now, even though each of these devices are set to trunk, they are indeed still sending DTP frames to each other. If we want to silence the sending of these DTP frames, we need one more command, don't we? And I'm sure you remember what it is from your BCMSN training. It's the switch port mode excuse me, switch port no negotiate. There we go. The switch port no negotiate command. Notice that this command doesn't show up as being used under our show interface trunk syntax. We have to instead do a show interface FA0/16 switch port command, for example. And if you look under here, it will say negotiation of trunking. It will say off, thanks to the use of the no negotiate command. And obviously, if I was interested in silencing these messages, I would go over to switch 3 and I would use the command on the appropriate interfaces there as well. And once again, that command was switch port no negotiate. Well, I hope you've enjoyed this demonstration of trunking and the wonderfully varied and diverse world of trunking on these Cisco devices. Now, a nice little security feature that's available to you for these trunk links is your ability to literally control what VLAN traffic can transit the layer 2 trunk link. As we saw in our demonstration, by default, all of the VLANs are going to be permitted to transit the trunk, but we can use the command switch port trunk allowed VLAN to actually manipulate what we call the allowed list. So you can literally say, hey, look, certain VLANs cannot transit certain trunks in your infrastructure. To quickly check what VLANs are allowed to transit the link, of course we can use the show interface trunk command we examined earlier. One of the optional features that you can utilize in your switched infrastructure is the VLAN trunking protocol, or VTP. What an interesting name. We had our trunking protocols, our true trunking protocols of ISL and 802.1q. Now we have something claiming to be the VLAN trunking protocol. A much better name for this technology would have been the VLAN management protocol, because that's what it's going to help you do. It operates over trunk links and allows you to create a VLAN on one device and have that device automatically propagate to other devices in the infrastructure. So really, it's to ease your administration, and it's totally optional as to whether or not you want to use VTP. The 3560 switch supports 3 versions of the VLAN trunking protocol. The default version on your devices is version 1. There's a version 2, and there's a really exciting version, version 3. And the reason why version 3 is so exciting is that it does enhance VTP's security model. Remember, with VTP, there are 3 modes that your device, your Catalyst switch, can be operating in. The VTP server mode allows you to create VLANs. And sure enough, a Catalyst switch is going to default to this mode. We saw a moment ago in a demonstration where we created VLAN 100, rather inadvertently, by assigning a port to that VLAN. And sure enough, we were in the default server mode, and that's why we could create this VLAN on that device. But every device is in a domain called null, the nothing domain. So none of the VTP, none of the VLAN information is going to propagate. So we're going to create VLAN 1 on one of the devices, and it won't propagate to any other device. It's not until we set the domain name that things start propagating. Now, notice that client mode is kind of, it's just, you can't create VLANs on a VTP client. Those VLANs will be inherited from your server or server systems. So the default mode, everybody's a server, but everybody's not sharing information, and we can go and change that by creating a domain and creating some clients. We're obviously going to experiment with this in a moment. But what about this transparent mode? Well, in transparent mode, you're essentially turning VTP off. You will forward VTP advertisements, but you won't listen to them. And on the transparent device, You won't be writing the changes into a VLAN database. Instead, you'll be writing the VLAN information into the global configuration of the particular device. There is some basic authentication available using an MD5 hashed password value, and this is available in versions 1 and 2. As I said, they've enhanced this security model in version 3 of VTP. Also, we want to talk about something next called pruning, but before we get to pruning, let's jump to the command line and let's just experiment with some of this that we've talked about so far. So here we are back on our device, and if I do, and here's your big verification command for VTP, show VTP status, it says, okay, here's what's going on. We are currently running VTP version 1. We are VTP v2 capable, and in fact, we're even VTP v3 capable. The configuration revision number controls the freshness of the database. In other words, if we are at a revision number of 3 and a server next to us is at a revision number of 4 and we're in the same domain, we'll end up syncing to that more modern configuration. We support 1005 VLANs, and there's 6 VLANs on this particular device. There's the 5 default VLANs and the one we created earlier, VLAN 100. We are in the server operating mode, and look at this, there's no domain. We're in that null domain. So sure enough, if I go over to switch 3 that we're trunking with, and I do a show VTP status, yeah, look at that. Only 5 VLANs over here, and it's because of this null domain. Now watch this. If I go in and say VTP domain is ATCOD, it will change it from that null domain. It will give us a console message that we made that change. And now if we rerun the show VTP status, we see that we are in the ATCOD domain now. We have a configuration revision number of 0, and we've still only got our 5 default VLANs. Let's do this. Let's go back over to 1, switch 1, and see if anything changed over there. Show VTP status. Yeah, something did happen over here. It's saying, okay, look, you just joined the ATCOD. What in the world happened here? We didn't make changes on switch 1. Well, switch 1 was configured to trunk to switch 3. And sure enough, they went ahead and it started exchanging the VTP information, and this device synced to that other device. This device said, okay, I'll go ahead and join the ATCOD domain. And they made that determination because they were trunked together. It was kind of Cisco doing some work for us here, saying, well, you went and built trunks between the two devices, and then you put one of the two servers in that domain. You must want both of them in that domain. Very interesting. Now, sure enough, if I create a new VLAN over here, VLAN 200, when we do our show VTP status, we're going to see that we increment the revision number now to 1, we bring up the number of existing VLANs to 7, and we should see that switch 3 has synchronized to that. And it sure has. Its configuration revision is now synced to the 1, and it now has both VLANs in its database. We use the show VLAN brief command to see those VLANs have propagated thanks to the VTP protocol. But what if you have some devices that are connected via trunk links to your infrastructure, but there are no clients of that VLAN on that device? Oh boy, think about it. You're going to be sending frames that are marked for the particular VLAN down to that device totally unnecessarily. And that's what VTP pruning is all about. VTP pruning allows the devices to dynamically suppress traffic from going down trunk links unnecessarily. The great thing about VTP pruning is it's so easy to configure. All you do is go to your server device and turn it on with the VTP pruning config. It will then propagate that setting to all of the devices running VTP in your infrastructure. Now, what if you're a bit paranoid? What if you don't want this automatic suppression of traffic feature for some certain VLAN? Well, you can go ahead and remove that VLAN from what is known as the prune eligible list. The command that you're going to use is switchport trunk pruning VLAN, and that will control which VLANs this pruning behavior will actually operate for. When you talk to Cisco engineers, you'll hear lots of great debate regarding the use of VTP. And particularly the debate is whether to use it or not use it. We don't care about such debates when it comes to the CCIE lab, do we? We're going to do whatever Cisco asks us to do, either implicitly or explicitly in the configuration tasks. But there's one thing that we definitely would say about the real world with VTP. You would really never want to consider using it unless you were going to, at the very least, provide the MD5 password in a version 2 type of environment, or even better, use version 3 with its upgraded security. Setting the password is simple. You're going to go to your devices and you're going to issue the command VTP password and then provide the shared secret, actually, that's going to be used for MD5. To view the password that's set on a device, use the show VTP password command. And obviously, to verify that the password is working, you can use your show VTP status to confirm that your devices are indeed synchronizing with each other. Now, one of the things that you'll come across as you're studying for the lab in this area is that we have a normal range of VLANs in 1 to 1,000, and then if you need more VLANs, you can use what's called the extended VLAN range. Now, for VTP versions 1 and 2, you need to be in transparent mode in order to use these extended range VLANs. With VTP version 3, you can indeed use these extended ranges. So you'll want to be aware of this as you are looking at task requirements to see, okay, do I need to be in transparent mode perhaps? Because they're asking me to do VTP version 2, but they're telling me to create a VLAN maybe numbered 3052. So watch carefully for this issue regarding the extended range VLANs. Some of the stars of the show for this area of our Advanced Technologies class on demand have certainly been listed here on screen. We've seen the switch port command, and you'll definitely want to log on to a device and start looking at all variations of this powerful command. We've seen show interface switch port, one of my favorites. We've seen show interface trunk, show VTP status, show VTP password, and we'll be looking at things like show interface status and show spanning tree in subsequent lessons of this module. Before we wrap up this lesson, however, there is no way we can forget about our layer 3 routed port capabilities on the 3560. We can create a switched virtual interface, an SVI, and this is done with the command interface VLAN, and this is where we can put, for instance, the default gateway address when we're having our multi-layer 3560 route between VLANs. All we need to make sure is that that VLAN exists in the database, and this interface will magically come up and will allow routing between VLANs, again, using our local device as a default gateway. Also, something that I want to demonstrate is our ability to go ahead and create one of the ports on the 3560 as not a switch port with the command no switch port, but as a good old routed interface port, making that port the same exact type of port that we would find on a Cisco router. Well, here we are back at our device, and one of the things that we want to look at here is the creation of both a routed interface. So we're going to go ahead and take one of our interfaces and turn it into a router port. And something else that we'll do is we'll take a look and we'll review the creation of a switched virtual interface, a VLAN interface. All right, let's go ahead and why don't we go over to, let's see, per our advanced technology diagram, let's go ahead over to switch 1. Perfect. And on switch 1, per our diagram, we are going to make a routed interface out of Fast Ethernet 0/3, as you can see from your Advanced Technologies Class on Demand diagram. So let me go over to switch 1. And on switch 1, we're going to issue the command interface Fast Ethernet 0/3. And I'm going to say no switch port. And we just took that interface and converted it to a layer 3 routed port. Notice it's going to go down, and then it should come back up. Now, just like normal router interface port here, I'm going to say IP address, and I'm going to go ahead and give it the address shown in the diagram, 155, our rack number 37.7, and a 24-bit network mask. So we're going to go ahead and issue the no switch port command here, give the IP address, and I'm pretty sure at that point we're going to have this particular interface come back into an up state. Let's see what's happening here. Let me end. And let's do a show run interface Fast Ethernet 0/3. All right, no switch port. We've got the appropriate IP address in there. And notice it's not coming back up. I can do a show IP interface brief to confirm this. And if we stop right here, we see there it is. There's the IP, and we're in the down state. Down. Okay, I'll stop singing. All right, let's see. Show CDP neighbors. What are we connected to outside this interface? Yeah. Darn it, that's not going to work. Because we're in the down state, I really can't see what we are connected to out that local interface. So this is interesting now. This is a time in which we would, if we were in the lab exam right now, we'd pretty much have to be provided with some kind of diagram here to help us out. I mean, we can't just magically discover things. We have to be able to discover things. And here we've hit a point where discovery isn't really capable, is it? Well, we do have a diagram of the physical topology of graded labs, and Fast Ethernet 0/3 connects directly to R3's Fast Ethernet interface. And sure enough, R3's Fast Ethernet interface is down. So if we go to the R3 interface Fast Ethernet 0/0 and we say no shut, IP address 155.15.37.3 with the appropriate mask, and we come back over here onto our switch 1, and we do a show interface brief, we're going to see, yeah, we did indeed move to the up state. And just like two routers can ping each other over this Ethernet connection, so can this router and this switch now ping each other over this Ethernet connection. So we just took a switch interface on our 3560 and we did a bit of magic. We converted it to a routed interface. Now, what about a VLAN interface? Well, a VLAN interface is created by saying interface VLAN 79, for example. Now, we can go ahead and assign an IP address to this VLAN. But we're going to notice a problem with this structure. This structure is going to remain in the down state. And the reason is because as we saw on that slide earlier, your VLAN interfaces are not going to dynamically achieve their up status without some help. Specifically, when we build them, we need to make sure that VLAN exists in the local database. So what I'm going to do is I'm going to go ahead and say VLAN 79, and we should see that interface come up. Two requirements actually have to be met here. The VLAN has to exist on the device, and a port or ports must be participating in that VLAN. Now, we should bring it up here because we have trunk links, and those trunk links will be participating in VLAN 79. So what I'm expecting here any second is for our switched virtual interface to dynamically come up, and sure enough, it did. Now, we mentioned that we can create one of these switched virtual interfaces so that your multi-layer switch can route between VLANs. Well, what about a router? What if we want a good old-fashioned router to route between VLANs? Well, this is referred to as a router on a stick configuration. It's really the legacy version of the switched virtual interface that we have on our multi-layer switches. Now, it's not fancy by any means. In fact, the router doesn't even support the dynamic trunk protocol like we have on our switches. What we're going to do is we're going to take the single interface on a router and we're going to carve it up into sub-interfaces. And we're going to educate each sub-interface as to what 802.1q or ISL traffic it is going to be responsible for. So in order to demonstrate this, let's go to the trickiest part of the topology, the trickiest section, if you will, I think for the layer 2 environment, is your switch 1 to R6 area. The switch 1 to R6 area is VLAN 67, and that VLAN 67 involves nothing less than a router on a stick configuration. So let's take a look at that area that we're talking about in our advanced technologies class topology. This is probably the trickiest part to deal with. First of all, notice on switch 1, we're going to create a VLAN 67, an SVI, VLAN 67. We then got to figure out who switch 1 connects to. That's actually going to be switch 2. And then switch 2 connects to R6, and here we're asked to do a router on a stick configuration. Notice the single fast Ethernet interface on R6 is going to use a 0.67 subinterface for this VLAN and a 0.146 subinterface for the VLAN 146. So we're going to focus our efforts right now in this little area of the topology, and it's certainly the toughest configuration that we're going to make to date. Okay, let's go ahead and take a look what we are going to do. I'm over on switch 1, and what I did was I used the simple command VLAN 67 in order to create the VLAN 67 interface there. And then I went ahead and created the switched virtual interface, so you didn't have to suffer through that configuration. Show run interface VLAN 67. Notice I created the VLAN 67 interface, and I gave it its IP address from the diagram. Okay, great. Now switch 1 connects to switch 2, for example, over the 0/13 link. We got to make sure that we're trunking over that link. Show interface trunk. Uh-oh, no trunk. Well, how about I go interface FA0/13, switch port mode trunk. That should force things along. Oh, great. I want you to see this error. It says, hey, look, I can't make it a trunk link if you're not forcing the encapsulation to something. So I'll say switch port trunk encapsulation .1q, and then I'll go ahead and say switch port mode trunk. All right, great. Now we should trunk, and we should watch it go down and then up. Now we should be trunking between switch 1 and switch 2. Remember, switch 2 is involved here because it's actually physically in between switch 1 and R6 in this scenario. Now we're going to go up to switch 2, and we're going to make sure that VLAN 67 is in the database of switch 2. We also are going to need to trunk from switch 2's fast Ethernet 0/6 interface over to R6. So I'm going to say interface fast Ethernet 0/6, and I'm going to say switch port trunk encap.1q switch port mode trunk. So we are ensuring that fast Ethernet 0/6, which connects out to the router R6, is in the appropriate trunk configuration. All right, now we've got to go and we've got to make our configurations of router on a stick on R6. We go to the physical interface first, and I'm going to no-shut it. So we're going to bring up that physical interface. And then I'm going to go ahead and I am going to create the sub-interface 67. So we create sub-interface FA0/0.67. Here we're going to assign the IP address. And it says, configuring IP routing on a LAN subinterface is only allowed if that subinterface is already configured as part of a .10, a .1q, or ISL VLAN. Aha! It's telling me, look, I need to use the encapsulation command. Notice .1q is the only encapsulation supported here. And I need to say, for what particular VLAN is this subinterface designed for? Ah, now things are looking better. And now I can go in and assign the appropriate IP address. Excellent. So, we have configured switch 1, switch 2, and now the R6 device to hopefully be able to communicate using this VLAN 67. What is the ultimate verification here? Well, it's simply to ping from R6 all the way down to that VLAN interface we created on switch 1. I'll do so with the ping 155.15.67.7. And after some address resolution protocol or ARP delay, we see that our ping is successful. And that was a pretty involved configuration, so let me go back to our diagram so that we can review exactly what we did there. So for this router on a stick configuration, here's everything that we had to do. We go to switch 1 and we put VLAN 67 in its database. We then create a VLAN interface, or an SVI, a switched virtual interface, for the VLAN 67, and we assign the IP address for this VLAN to that VLAN interface. In between here, not shown on the diagram, is switch 2. We make sure that switch 1 is trunking to switch 2 via the fast Ethernet 0/13 interface. We then put VLAN 67 on switch 2, not shown in the diagram. We then configure switch 2 to trunk using .1Q over to this R6 device. We then move to the R6 device, and we create a sub-interface, Fast Ethernet 0/0.67. We set it up for .1Q encapsulation for VLAN 67. We assign the IP address, and then we tested this configuration by pinging from R6 to the VLAN interface on switch 1. Well, folks, that concludes this lesson of our Advanced Technologies Class on Demand session. We hope you'll join us in the next lesson, where we are going to look at some more Catalyst switch technologies.